Welcome to our channel. In the last session, we discussed inner classes. Okay. In that inner classes, we have two types. One is member inner class. Second one is anonymous inner class. In member inner class, we can place the inner class as a member and we can place the inner class local to the method. And coming to anonymous inner class, we discussed the anonymous inner class as class extension and anonymous inner class as implementation class. Anonymous inner class is implemented as class extension and anonymous class as implementation class. Now, this anonymous inner class with implementation class model, it is modified as Lambda Expression from Java version 8 onwards. You got the point? The anonymous inner class as implementation class model. This model is modified as Lambda Expression by Java 8 version. Now, what is this one? What is the Lambda Expression? Now the question is Lambda Expression. Simply the process of declaring a method. The process of declaring a method without method name. So understand the differences in inner classes and anonymous means inner class without any name. So we can implement either child class or implementation class. Suppose in your program, if you have a method, declaring the method without method name is called as Lambda Expression, and it is also called as anonymous method. Now, what is the structure? Simple thing. First, you need to write the method name, but the Lambda expression does not consist of method name. So, general syntax: method name, some parameters, opening, we are writing the body, and then close. Some return type. This is the regular method. Now, the structure of Lambda expression is the return type and method names are avoided. Simply, we are writing the parameter list within the bracket and arrow mark symbol, open. Here you are writing the body, close. This is the syntax. This is the structure of Lambda expression. Structure of Lambda expression. Now, here you need to remember one point. So, what I said, the Lambda expression is a implementation class model. That means related to interfaces. So, the interface abstract method, the interface abstract method is attached with Lambda expression. So this is the new feature from Java 8, and almost all the projects, instead of using child classes, they are using this Lambda expression. Why? I will explain the advantage also. So the interface consists of some abstract method. This abstract method is attached with the Lambda expression, and we are execute the Lambda expression. Once that is attached, we are executing the Lambda expression with abstract method name. Now understand. So one interface is there. The interface consists of an abstract method. Generally, what you need to write? You need to write one implementation class. Within that class, you have to provide the definition for the abstract method. In the previous class, what I written? In the main method, I create an anonymous inner class, and within that class, I provided the definition for the abstract method in the interface. But here, even method name is also not required. Directly, I provided implementation to the abstract method by using lambda expression. For example, assume we have one interface. Interface name is some arithmetic. This interface consists of one abstract method. Suppose public abstract void some method int x int y. Okay, so this is an interface with one abstract method. How to write this lambda expression? Observe I arithmetic OB is equal to. So ignore this one right now. How to write the lambda expression? Like this. The parameters of the abstract method int x into y, arrow mark. Here you are writing the body and then close. This is the lambda expression. Now simply the lambda expression is assigned to some reference OB. Assigned to some reference OB. Okay. Anyway, I will explain with one example. Before that, you need to remember some rules. And what is the advantage? What is the advantage? For example, if you are using normal inner classes, what happened? They generate subclass. They generate subclasses. So each subclass have a separate dot class file is loaded. At the time of execution, all the dot class files are loaded into JVM. It execution times taken. Why? For example, your program consists of 4 subclasses. You need to store all the 4 dot class files. But coming to lambda expression, it does not generate a separate class. You got the point? Normal inner classes generate subclasses, but the lambda expression does not generate a separate class. So what happened? The loading time is reduced. The loading time, there is no class. So loading time is reduced automatically. The performance of the application is improved. Now you understand? This is the reason for using lambda expression. It implements very fast. Now you need to follow some rules. The first rule, the lambda expression is attached with the abstract method of the interface. Suppose if the interface consists of more than one abstract method, now we return the lambda expression for which abstract method? There is no name. You got the point? The lambda expression, the method name is not there. Suppose interface consists of more than one abstract method. You provide the definition for which one? It leads to confusion. So the interface consists of only one abstract method. Then only the lambda expression is possible. Then only the lambda expression is possible. Next one. Lambda expression cannot access the variables. Cannot access the variables from the interface directly. Suppose interface consists of some variable and along with abstract method. So the lambda expression cannot access the variables of the interface directly. Why? The lambda expression is local to the method where it is declared. Suppose if you declare it inside the main method, now the lambda expression is local to the method. How can we access outside? Generally, if you want to access, we can access by using interface name. You got the point? Anyway, I will show you. Now, the next point is the names of parameters. The names of the parameters in lambda expression. The same names must not be used for local variables in the same method. In the same method scope. You got it? Whatever the parameters that are used in the lambda expression, the same names are not allowed to use. The same names are not allowed to use in the method. Now you got it? Based on this one, I will write down one program, file, new project, select Java project, Java lambda expression. This is my project. Okay. Now expand, create one package, new. So assume my package name is some pack1. Within pack1, what is the step? Whatever you written for anonymous inner class, in the same fashion, instead of inner class, we are using lambda expression. Suppose see this one, create one interface. Suppose interface name is arithmetic. You can give any name. I created one interface. Within this interface, public, static, final. You can use one variable. Int some z is equal to. You can write one variable. One static variable, write down one abstract method, public abstract void some abstract method with some number of parameters. Now you got the point. If you have a lambda expression, that lambda expression implements an abstract method of interface. That interface consists of only one abstract method. And remember, along with, if you want, you can write default method, static method, not a problem. For example, void dis of int k. So you can write regular default method. Suppose system.out.println in default dis. Just to print the value of k, system.out.println k is equal to plus k. Suppose if you want, you can print the value of z. Why? Because z is also available in the same interface. Z is also available in the same interface. Anyway, the default method can access this one. Now, one interface is created with abstract method. That is not my aim. My aim is to create lambda expression, new class. For example, give the class name as lambda expression, which consists of demo lambda expression, which consists of main method. Now, first step, as usual, import pack1.star. Import pack1.star. Now, within the lambda expression, if you want, you can write separate variables within the main method or outside of the main method. Remember, this is also a class. This class consists of main method along with normal variables also. You can write, suppose the public static int some p is equal to suppose some 400. You can write some variables, right? Now coming to the point, within main method, create one variable into q is equal to some 500. What is this variable? This is a local variable, local to the main method, variable within the main method. Now, how to write the lambda expression? What are the parameters int x, comma, into y minus arrow mark, open and close. Here give semicolon. This is the lambda expression. This lambda expression is assigned to, what is the interface name? Arithmetic. See this one? This lambda expression is assigned to this one. Now, here you got it. For example, within arithmetic, you have one more abstract method with the same parameters. Now, this expression belongs to which one? That is the reason. What is my first rule? An interface consists of only one abstract method. That is my first rule. Okay? The first rule is satisfied. Within this one, you can implement the method. For example, system.out.println calculate method is implemented. Here I am implementing the calculate method. Write down the logic. System.out.println what you want. For example, you want total. Whatever you want. For example, x plus y. Directly write the logic. There is no method name. By taking these two parameters, here what I am doing? I am doing the addition of two values. Now system dot out dot println p is equal to plus p. Here you are printing p value. Why? P is also in the same class. P is also in the same class. We are printing p value. Now, print q value. System.out.println q is equal to plus q. You are printing p value and q value. Why? Q is local to here. Q is local within the method. You can access. P is also in the same class. You can access. There is no problem. Once we come out of the method, ob dot call this abstract method with some parameters 2, 3. ob dot calculate of 2, 3. ob dot, I think I written one default method. So dis. Okay. ob dot dis of some 4. Now everything is happened successfully. Calculate is an abstract method. By using this lambda expression, I provided the definition and assigned it to the reference variable OB. By using OB, I calculate, call the method. Now the most important, suppose, now fine, everything is happened successfully. System.out.println, I will do another operation. Main, here I want to print P and Q values here within the main. So within the lambda expression, I print P and Q, and along with I print P and Q. Check what happened. Execute. There is no errors. First ob.calculate is happened. It calls the calculate method. Total 5 is printed. P is equal to 400. Q is equal to 500. Everything is happened. After that, you are calling dis of 4. The display method is called and k value 4 is printed and their z is also printed. Now you call the main method. P is printed. Q is printed. Now, up to now, this is fine. Suppose here, if you try to print z value, see this one? Here, z value, what is my second point? The lambda cannot access the variables directly. Cannot access the variables directly. See error? Z cannot be resolved as a variable. Okay, save. And if you execute, anyway, proceed. See, the unresolvable Z. Unresolved Z. You got the point? For example, I arithmetic dot z. Now it is okay. Now you got the first point is only one abstract method. Second point is within the lambda expression, you can access the interface variables by using class name. Sorry, by using interface name only. Interface name only. Clear. Now run this one. Anyway, save. Executed successfully. And what is my third point? The names of the parameters in the local expression must not be used for local variable. So what is the meaning? Here, what are the parameters name? X comma y. So int x is equal to some 5, comma y is equal to 6. See this one? It is an error. Why? Lambda expression parameter x cannot redeclare another local variable. You got it? Whatever the parameters you are using, that must not be used here. That must not be used here. Okay, this is error. These are the 3 points. Now, how the program is executed? First, the main is loaded. Understand the structure. First, the main is loaded. Anyway, this is the local variable within the main. Whenever this statement is executed, internally, if the statement is executed in the sense, arithmetic interface is loaded, their memory is assigned for Z only. And by creating this one, the two methods, calculate and dis, go to the heap area. Whenever you are calling this one, the corresponding methods are executed. Now, in this one, you need to observe one point. What are the classes it generates? Arithmetic dot class. This is one class. Demo lambda expression dot class. Only two classes are generated. Only two classes are generated. This is the advantage. What is the advantage? Separate files are not created. If you want, you can check. Go to C drive, users. What is my project name? My project name is Java Lambda Expression. Java Lambda Expression. Go to bin, pack 1. Check the files, only 2.class files. Even though 2.class files, but I implemented the abstract method. I implemented the abstract method. You got it? This is the concept of lambda expression. Anyway, in the next session, we will discuss one more program with lambda expression. That's the end of today's session. Thank you.